Good morning and welcome back from spring break. In this video, we're going to go over circumference word problems. I know they were tough in the last assignment, and it also gives us a chance to sort of review all the stuff we learned right before the break. So basically, I'm just going to solve a few word problems in this video while discussing some strategies that we can use to make solving word problems easier in general. So starting with drawing the word problem, that usually helps because we make a model, and this is another use of the word model, of what's going on. And it helps you imagine the exact situation. And we'll do a lot of that in the video. Determining key information basically keeps you from getting more information than you need and being confused by it. Simplifying the problem helps when we don't know exactly what's going on, and so we create a simpler problem that we can solve and use that information to solve a more complex problem. And then writing equations, that's also another form of modeling, which helps show the relationships between different things in the problem. Now, in general, we're going to use more than one of these strategies when solving a word problem, just because different strategies shed light on different information. But most importantly, whenever you're solving word problems, give yourself some time to think and imagine what's going on. It's not going to come to you right away like solving a straightforward problem like solve an equation. A word problem takes some imagination, and you need to give it the time it deserves. Okay? So the first question says, the bottom of a flower pot has a radius of 16 centimeters. What is the circumference of the bottom of the flower pot? Okay? In terms of strategies here, I'm going to choose to make a little drawing. So I'm going to choose to draw first, and then see what comes up. So let me draw this right now. So the problem says the bottom of the flower pot has a radius of 16. So just the bottom here, this is this area here, has a radius of 16. And whenever we use the word radius, we know they're talking about a circle. So if we push this flower pot over, what we would actually see is a circle, right? Usually it has a hole in the middle or something to let the water out. So we have a circle on the bottom of this flower pot. And it has a radius of 16. If you remember radius, it's the length between the center of the circle and the edge. So this length here is r. Okay? So far so good. We have a circle in the bottom and the radius is 16. And now they're asking for circumference, which is the length of the edge of the circle. Now we're going to use the equations we already knew. So we finished step one, or strategy one, which is drawing. And let's look at a different one right now. I was going to write strategy. Is to write equations, right? And so our equation here, we know that pi equals c over d, right? Right now we don't have a diameter. We're only given a radius. But we also know that d equals 2 times r. The diameter is twice the radius, right? So if we take this out, then all of this length over here would be the diameter. So instead of d here in this equation, we can write a new equation saying pi equals c over 2r. Okay? We're given r as 16, so now all we have to do is solve. So I'm going to rewrite this as 3. We can simplify this. Okay? Now all I have to do at this point is isolate the variable, isolate the c. So I'm going to multiply both sides by 32 because c is being divided by 32. So what's 3.14159 times 32? Well, then we get c equals, and then I use my calculator here, and I get 100.53088. Now it says give your answer correct to 1 decimal place, so I'm just going to round here. And so the next digit is 3, which means we round down. So my answer is 100.5 centimeters. And I use centimeters because the radius is in centimeters. Okay? Let's move on to the next question. In this question, it says a coin has a diameter of 2.2 centimeters. If the coin is rolled through 45 revolutions, what distance will it travel? Give your answer correct to one decimal place. So again, I'm going to draw. Drawing is really my favorite strategy when solving word problems. And it's going to roll like that. Okay? And I hope this reminds you of the simulation I showed you in the last video. This is from MathSpace. Remember this little circle? If we roll it one whole time, watch the circumference of it unwrap. So right now the whole circle is wrapped with the circumference, and as we roll it, you can see the circumference is sort of unwrapping. And so if I roll it one complete revolution, the distance it traveled over here from the start to the end is equal to one whole circumference. Okay? So starting here, let's say I roll it all the way to here so that it's back upright again. Then this distance is C. Okay? Just so you know that. So if I'm rolling it 45 times, so I'm rolling it again and again and again, basically the whole distance, so total distance equals 45 times C, right? Because it's 45 times. And if one time is C, then this is 45C. So we sort of here, right now, wrote an equation, right? Total distance equals 45C. That's very good. Now, we still don't know what C is, but they gave us the diameter. The diameter is 2.2. And so we can use same equation from last time. Pi equals C over D. You can even write this in a different form. You can say C equals pi D. If you just multiply D by both sides, it sort of cancels from here, so you just get this new equation, C equals pi D. It's easier to use. So let's find C. So we can write C equals 3 with our calculator. C equals 6.911498. I know it says one decimal place. I'm going to leave it as that for now, and in the very end, I'm going to round to one decimal place. So we have C. Now we need the total distance. So I'm going to call it TD, total distance, equals 45 times, and I get 311.01741. One decimal place, so we're going to round from here, which means there's a 1, so we round down. So the final answer is 311.0 centimeters. This is if you take the coin and roll it 45 times, you go above 3 meters. Okay? Let's do one more. This one says the diameter of the front wheel of the car is 0.4 meters. How many complete revolutions will the wheel of the car make if the car travels a distance of 50 kilometers? So the car wheel with a diameter of 0.4, it goes 50 kilometers. So it's the same sort of concept of the coin rolling, but this time they gave us the total distance, right? The total distance is 50 kilometers, TD. And they're asking us how many revolutions does the wheel make? So every time the wheel makes a revolution, it's like C, and then another C, and then another C, right? But they gave us the total distance this time. So to find how many revolutions we made, we have to say like number is equal to whatever the total distance is divided by C. Okay? And let me give you an example here. So So we made a drawing, right? We did draw. We made an equation. Now we're going to use a new strategy, which is simplify. And let me actually get a blank page here. If I have a wheel, and let's say the circumference is equal to 5. If it just goes 1 revolution, it'll move 5. So 1 revolution is equal to 5, let's say, meters. If it goes 2 revolutions, then that's another 5 meters. So 2 revolutions is going to be 10 meters, right? If I say that this coin or circle or wheel or whatever went a distance of 20 meters, how many revolutions is that? So we'd have to say 20, which is the total distance, divided by the circumference, divided by 5, which means it did 4 revolutions. Does that make sense? So 1, 2, 3, and then 4. And that's how it was divided. That's how it made 20 meters. So we simplified this problem here just to sort of get a grasp of what's going on. Now let's go back to this problem. To get the number of revolutions, we have to divide the total distance by the circumference. We know the total distance already, but we do not know the circumference. And one more thing we have to notice here. The total distance is given in kilometers. The circumference is given in meters. So we have to make sure that we're using the same units before we divide. Okay? So let's first get the circumference. We know that C equals pi d, which means, again, I'm using meters. I'm going to convert this to 50,000 meters. I put this in my calculator, 3.14159 times 0.4, and I get 1.256636. Okay, so I have C now. So now I have to solve this little equation, right? I'm just going to call it R instead of number of revolutions. R equals 50,000 over C, which is, in this case, 1.256636. And so how many times did this front wheel turn? 6,366.203101. Okay? So how many times did it turn? How many complete revolutions did it do? If we're talking about complete revolutions, then we just take the whole number here. We're not going to take any decimals, because then it wouldn't be complete. So our final answer would be this: 6,366 revolutions. All right. Let's go back here to the strategies. Let's see what we used and what we didn't use. We used the drawing a lot. We used simplifying the problem once. We used writing an equation a lot. Determining key information. So if we look at question 1 here, it said flower pot. It didn't say circle, right? It's not really very clear. And so the key information here to realize is that the bottom of the flower pot is a circle. Okay, so just keep that in mind. All right, good luck. Let me know if you have any questions, and I'll see you in class or on Zoom. Bye.